Hi, I'm Mark Keane. I'm a Microsoft Azure MVP and a Microsoft Azure architect working at Vigilant IT based in Sydney, Australia. This webinar will take you through discussing what OMS is with a focus on insight and analytics. We'll run through some slides to give you a good overview of the product and also show you some demos to help you really come to terms with the awesomeness that is OMS. What is OMS? OMS stands for Operations Management Suite. It gathers data from servers throughout your IT infrastructure and consolidates that data into a single management interface. That data might include diagnostic, log, performance, or alert data from both Windows or Linux computers. Alerts in OMS can automatically inform you by sending email notifications, and OMS can auto-remediate issues with Azure Automation runbooks. So what do you get in OMS? Insight and analytics. Gain immediate insights across workloads, tap into operational intelligence when it matters to explore, analyze, and take action faster. You also get automation and control, enable consistent control and compliance, deliver continuous IT services, and remediate issues quickly at scale. You also get security and compliance, respond faster to security threats, identify emerging threats to protect your critical data and workloads. And you also get protection and recovery, ensure availability of your apps and data. It's simple, automated data protection and disaster recovery in the cloud. So those are the 4 value props of OMS, but this presentation focuses on the first one, Insight and Analytics. OMS Insight and Analytics is a hyperscale machine data analytics platform. It allows you to collect, search, and analyze any machine data. It could be metrics, events, or any unstructured data. It's a true hybrid platform which supports multi-public cloud as well as on-premises and offers workload insights from both Windows and Linux. It also works with existing monitoring products such as SCOM, Nagios, and Zabbix. These statistics literally blow your mind. OMS has been generally available for over a year now with more than 50,000 customers. OMS handles and has ingested more than 20 petabytes of data, and a year ago it was only 5 petabytes. So it's growing super fast. 1 year ago it's gone from 30 million queries a month to more than 188 million queries per week currently. It's a seriously powerful system. It allows you to gain deep insights into the data from your environment through intelligent search, analysis, and visualization. In this demonstration, we'll walk you through onboarding to a trial version of Operations Management Suite for immediate and actionable insight across Windows and Linux machines, VMs hosted in Azure, and VMs hosted in AWS. There's 3 simple steps to get you started. You sign in with your own account, create a workspace, and connect your servers. So let's get started by signing in. Now we'll create a workspace. You can tie in an Azure subscription with Operations Management Suite for a unified experience. However, this is not a mandatory requirement. We have successfully opened an Operations Management Suite workspace. In order to perform further analysis, we'll need to add a solution, connect to a data source, and define data to be collected. Let's enable recommended solutions for now. You'll need to connect to the sources. Let's download the agent and install it on one of the machines running on AWS. What you need to do is simply install the agent along with a workspace ID and passkey provided in the OMS GUI. For those who want to utilize scripting, group policy, or a tool like System Center Configuration Manager, you can do that as well. There's a few other ways you can connect your managed endpoint. You can connect to an existing System Center Operations Management environment or connect directly to Azure Storage. It looks like the agent has finished installing. Let's verify this machine's information. Now let's connect a few instances running in Azure. We can simply enable the connection via the Azure portal. Just like the agent installation, you can leverage the Azure Command Line Interface, CLI, so you can connect multiple instances at once. Let's open the Log Analytics blade that we have just created. Once you hit the virtual machine tile, you'll see all the instances running in Azure. We'll link to Operations Management Suite for trial machines. We'll enable Linux and Windows with the same experience. Now we'll connect with an Azure Storage account. This way we'll automatically collect all necessary data that lives on the storage without further interaction for you to connect with the endpoints. Once we hit Add, we'll see all available storage accounts running on Azure subscriptions. We'll add OMS Demo Storage 01. We will select Events, but you can also select IIS logs, sys logs, ETW logs, and Service Fabric events. And we'll hit OK. Now that the endpoints are connected, we'll define which type of data we want to collect. Keep in mind that when we enable solutions, it will automatically define which data to pull from the managed machines. However, this tab will let you define specific data types to be collected. You can specify event logs, performance counters, custom logs for both Windows and Linux machines. As an example, I'll add security-related Windows events. Now let's get back to the dashboard and see what other solutions that are available. Let's enable security and audit so we can see immediate security insight from the machines we have connected. It typically takes a few minutes to initialize the data. What happens behind the scenes is that Operations Management Suite will match all relevant security patterns for you to gain insights from. The sources of this intelligence comes from Azure, Office 365, Skype, Xbox Live, and many other global services. You can immediately see attacks are being performed for machines in Azure as well as AWS. We can drill into identity access analysis and see which account has been trying to access your managed resources. Within a few minutes, you can see that there has been a failed logon attempt, and you can drill down deeper where and when the actions have been performed. You can also export to Excel or associate with Power BI, or keep this query with your favorite list. As you can see from this onboarding walkthrough of Operations Management Suite, you can easily create a workspace, connect your machines, collect data, and see immediate insights from the solutions enabled. Insight and Analytics is a real game changer. The direct pipeline offers close to zero latency for telemetry events that flow directly into OMS. Out-of-the-box solutions set up in seconds, written by the Microsoft product teams themselves. Hyperscale running in Azure, making use of over 20 data centers globally and supporting true hybrid on-premises or any public cloud. And long-term data storage to help look at trends and to analyze anomalies in your environment. OMS is available worldwide and recently announced the US government. OMS is hosted in Azure, which is certified many times over with the International Organization for Standardization. Azure is certified in ISO 27001. This certification outlines hundreds of controls and control mechanisms to help organizations of all types and sizes keep information assets secure. In February 2015, Azure became the first cloud computing platform to conform to the ISO 27018 Code of Practice for the protection of personally identifiable information in public clouds. And in September 2016, Azure was the first hyperscale cloud provider to achieve the ISO 22301 certification with the assurance that you can now trust Microsoft Azure with your mission-critical applications and Azure's unmatched business continuity and disaster recovery preparedness. OMS has integration with cross-platform monitoring systems. Microsoft monitoring Linux is nothing new. Back in 2009, Microsoft introduced support for SCOM management packs for Linux. Currently, you can collect logs in OMS for the following types of data from Linux computers: performance metrics, syslog events, alerts from Nagios and Zabbix, Docker container performance metrics, inventory, and logs. OMS also offers integration with some third-party cross-platform monitoring systems, enabling alert collection for these systems for visualization, alerting, and potentially auto-remediation in OMS. Currently, OMS offers alert collection from two popular open-source systems, Nagios and Zabbix. Nagios is an open-source computer software application. It monitors systems, networks, and infrastructure. Nagios offers monitoring and alerting services for servers, switches, applications, and services. And Zabbix is an enterprise and open source monitoring solution for networks and applications. It is designed to monitor and track the status of various network services, servers, and other network hardware. Let's take a look at Operations Management Suite under the hood, the architecture of OMS. We start with the on-premises environment or any public cloud. The OMS agent is installed on any computer, physical or virtual, Windows or Linux. Logs come from either direct agents, an existing SCOM server on premises, Azure or Office 365. Everybody's data is then normalized by some extremely powerful servers. Currently, the data is up to about 20 petabytes. Data is being enriched to suit the various OMS solutions that are active on the current OMS workspace. All this data is put into an Azure file storage account, which is then encrypted with the highest possible encryption. The data then goes through advanced detection, where useless data is filtered out, such as brute force attacks. There is a set of APIs to allow you to pull or submit data to or from the storage. And there is a whole bunch of queries that access the data, UIs such as web or mobile, webhooks or alerts, and data export. In terms of functionality of Insight and Analytics, Microsoft have invested heavily to enable you to grab the data from whatever device or endpoint that you need. Previously, there was less than half the amount of the collection endpoints available to what you see here on this slide. One of the new data collectors is the new HTTP Data Collector API, which we'll demonstrate for you very soon. It's a programmatic way to send data via PowerShell, Python, C#, etc. Data from anywhere that the scripts have access to. You can send that data in JSON format to OMS via the API, which ends up being a custom log in OMS. Rather than having diagnostic telemetry logs being sent to a storage account first in Azure and then having to rely on a third-party solution to pick up the logs, with OMS there is a first-class pipeline with Azure. You can send close to zero latency diagnostic metrics and activity logs straight through to OMS. On top of this, the data is processed in real time, the relevant fields are taken out of the logs and put into the database, so the data is searchable almost instantly. OMS also pulls data out of both Office 365 and App Insights. App Insights has a limitation where you can only look at the views on a per application basis. However, with Insight and Analytics, you can interrogate all the applications, pipe it into a single workspace in OMS, and search across all applications to get insights. OMS is a platform where you can run multiple solutions with multiple engines to provide insights. Data segregation. Customer data is kept logically separate on each component throughout the OMS service. All data is tagged per organization. This tagging persists throughout the data lifecycle and is enforced at each layer of the service. Each customer has a dedicated space in Azure file storage that houses a long-term data. The storage is encrypted with unique per customer keys, which are changed automatically every 90 days. Data retention. Aggregated metrics for some solutions, such as capacity management, is stored in a SQL database hosted by Microsoft Azure. This data is stored for 390 days. Indexed log search data is stored and retained according to the pricing plan. Physical security. Microsoft personnel manage the OMS service and all activities are logged and can be audited. The OMS service runs 100% in Microsoft Azure and complies with the Azure Common Engineering criteria. As of today, OMS solutions can be divided into 4 major categories or themes: Insight and Analytics, Automation, Backup and Disaster Recovery, or Security and Compliance. As for Insight and Analytics, Microsoft develops solutions for data analytics via the Solution Gallery. Some solutions include Agent Health, to take a look at the health of the OMS agents, AD Assessment, the health of your Active Directory environment, which leverages AD best practices, or Security and Audit, which gives you insight to all security-related data. This demonstration, we're going to show you all about solutions in OMS. Now, solutions are similar to management packs in SCOM, System Center Operations Manager, on premises. However, the difference being solutions are written by Microsoft themselves. Management packs are written by Microsoft as well as third-party vendors. There will be a time soon when solutions will be written not only by Microsoft, but also third-party vendors. Now, currently at the moment, the product teams in Microsoft are hard at work. They've made a huge investment in pushing out solutions. They're coming out at a rapid pace, maybe 2 solutions a week. It's very, very easy to install into your OMS workspace. It's quite simple. You go to the solutions gallery, you select a solution, there's descriptions for each one and screenshots. You simply click on add, and within seconds, you're reaping the rewards of that solution. So let's take a look. So here we are in the Solutions Gallery, and the Solutions Gallery lists all the solutions available for OMS. And as we go through here, you can see all the solutions are in different statuses. So this one here, Protection and Recovery, is available. This one here, AD Replication Status, is owned. This one here is coming, Network Performance Monitor. So every week, generally you'll see new solutions popping up all the time, written by Microsoft themselves. All right, let's go to Home. And on the home screen, we can see all of the solutions that we've added to our workspace. The solutions are a way of aggregating the vast array of data available to us into OMS, whether it's through the agents installed on client machines, whether it's through machines connected to SCOM, and then SCOM channels all the data up to OMS, or whether it's through the HTTP Data Collector API, or even through Azure directly. Now, however the data gets to OMS, the data is in OMS, it knows all about it in native format, and the solutions packs is a way of aggregating the data into such a way so it makes sense to you, and it displays it based on, say, best practices from the product teams at Microsoft. Or let's check out this one, for example, the Security and Audit. Now, the Security and Audit solution is quite a popular one because it's all about different security aspects in your organization. You can go from 0 to 100% awareness of security in your organization. On the left-hand side, we've got a whole bunch of security domains, and the security domains are a way of breaking up the security and audit solution pack into more logical areas. One of the more exciting new capabilities is threat intelligence, which enables you to see network communications to and from malicious IP addresses. It compares network traffic to global threat intelligence from Microsoft, partially sourced from Microsoft's Digital Crimes Unit. You can visualize the source of these attacks by geography, as we can see here on the map. Orange means inbound communication, and red means that the computer is compromised and communication outbound with a known bad actor. So we can click in on any of these entries to get more insights. And then we can also narrow down that search based on the time frame if we wanted to look at just those events that occurred at the same time or close to the same time as the outbound traffic we saw earlier. Let's take a look at this new baseline assessment feature. Microsoft is working with industry partners including the US and UK Defence Departments and many others. Microsoft defines and publishes a set of recommended security baselines for Windows servers. OMS is assessing the security of your servers against a set of baselines and shows mismatches or any vulnerabilities at services. They're prioritized for you here. Most rules are built in. And you can create your own custom rule. For example, if you wanted to keep a close eye on logon attempts using your CEO's credentials, for example. If we take a look at the identity and access security domain, we can see if failed logon attempts exceed the normality. We can see which systems are being targeted and which user accounts are being used. Like, for example, if it's a dictionary-based attack. All right, let's take a look at the AD assessment solution for OMS. Now, the AD assessment solution is built by the Active Directory product team at Microsoft. It's all based on Active Directory best practices. As of right now, it's completely up to date to the minute. It also assesses the risk and health of your Active Directory environments on a regular interval. It provides a prioritized list of recommendations tailored to your deployments. These recommendations are categorized across 6 focus areas, which allows you and your team to quickly understand the risk and health of your environments and easily take action to decrease risk and improve health. So the focus areas are listed here. You've got security and compliance, availability and business continuity, performance and scalability, upgrade, migration and deployment, operations and monitoring, and change and configuration management. The other solution we'll take a look at is update management. Update management identifies missing system updates and orchestrates the installation of these updates across Windows and Linux servers, both in your data center and in any public cloud. Systems that are missing security updates can become targets of intrusions in your network and data. With simple out-of-the-box dashboards, you can quickly assess which servers need your immediate attention. With Microsoft's update orchestration capabilities, you can now manage the installation of updates across computer groups. So this solution requires both automation and log analytics. And as we see here, we can see both Linux machines and Windows computers on the same dashboard. This is a sneak peek at the new HTTP Data Collector API. It's just another way that you can get data into OMS using your favorite scripting language. For example, PowerShell. Data has to be in the format of JSON. In this demonstration, we're going to take a look at the HTTP Data Collector API for OMS. Now, as you know, OMS, you can get data from practically anywhere. You can pull data from anywhere, but this demonstration will go through and show you how we can grab data off the internet and use the HTTP REST API and push data directly into OMS as a custom log. Now, you can use your own favorite scripting language, whether it be C# or anything else. We're going to be using PowerShell for this demonstration because, as you know, PowerShell, you can grab data from practically anywhere, whether it be the local computer, whether it be the internet. And so we're going to grab data from the internet. We're going to be using the iTunes pop chart, the top 100 pop songs, which is listed on the internet as an RSS feed in XML format. We'll use PowerShell and grab that information. We'll massage it, take the information we need and clean it up. We'll convert it to a custom object in PowerShell. Then we'll convert that custom object into JSON, and then we'll take that JSON and push it up into OMS, and we'll show you what it looks like up in OMS and use the powerful log search facility. And here is the PowerShell script which we're going to be using to grab the data off the internet and push that into OMS. To begin with, though, we need to make sure the variables are all set and are in place. So the top variable is the workspace ID for OMS, which is the unique workspace ID for every workspace that people have. The next one is a shared key, which is like a password for that workspace. The next one after that is log type. Now, log type is going to be converted to the name of the custom log later on in the process. So the log type I've got here is iTunes Pop Charts 2. So later on down the track, when I want to search in log search, I just type in this search string here, which is type equals iTunes Pop Charts 2 _ CL. So the _CL is standing for custom logs. I've got my URI here, which is the URI that my script needs to go out to the internet to get some information. And as we scroll down, there's a whole bunch of functions here. One is to get the data. One is to build the authorization signature to authorize the post. And also two down here, it's got the send OMS data. So we're happy with that. Let's go publish. And yes, we'll start this runbook. And go to output, and we'll see the output on the screen. Now, it's going to take a while to kick off. While we are waiting, we'll have a look at the exact same script in PowerShell. This is the exact same script as what you saw before in Azure Automation. The only difference is it's running locally on my machine as in PowerShell ISE. I want to show you this while we're waiting for the Azure Automation script to the runbook to complete. This section here of the script is the part where it goes out and gets the information. So what I'll do is run through this just quickly. So we're going through and getting information from the iTunes pop charts, the top 100 songs. And as you can see here, this is the information we're getting in real time. If I break that out even further, I can see here a list of all the songs on the iTunes pop charts. But the problem is, for each song, if you have a look at the fields here, the fields are not necessarily the ones that we would like. And some of them are not formatted correctly, and maybe it's too much information. We don't want this information. We want to change it around a little bit. So this is what we can do in PowerShell. We can massage it to how we want. And this is what we've done exactly here with the help of some regular expressions and some converting of dates and so forth. And so what happens is it takes this information here, it massages it and builds it out to another custom object. So let's do that right now. We'll highlight this and run it. So it's taken that information, turned it into a custom object, which is this here. And already you can see it looks much, much more neater and tidier. All the fields that we need. But the problem is we can't upload it to OMS in this state. We need to convert it to JSON. So that's fine. Down the bottom here, we just run this line here, line 69, and voila, there's a JSON converted version of what we want. So that there is exactly what we'll be using to send up to OMS. So if we go back to the Azure Automation account, and yep, as you can see, it's completely finished sending the data up to OMS. And down the bottom, it's got a HTTP code of 202, which means successful. So let's go to OMS and have a look for this data. So if we click on search, and we'll be able to see the data listed in OMS. So let's type in our search string that we talked about before, which is type equals iTunes popcharts2 _ CL, which is the name of the custom log. And if we click on search, it should list all the data, and there it is there, 198 results. And have a look, it's exactly the same as what we showed you in PowerShell, the same nicely massaged and formatted fields, song, label, year, date, genre, and it looks beautiful. Now, we can go one step further than this if we like. We can go through on the left-hand side where it's got labels, we can go more, and let's say I want to produce a report for all songs by Capitol Records, for example. So if I click on Capitol Records, I'm going to highlight this name here. Okay, this search string here, I'm going to save it. I'm going to call it Capitol Records. I'll save it under General Exploration. Click on Save and go to the dashboard. And I can add that search string to the dashboard. So it's under General Exploration, under Capitol Records. I can add that to here. And as you can see, I've got 6 songs here from Capitol Records. So if I click on it, it takes me back to this log search. But the benefit being is later on down the track, as I get more and more data going up to OMS using the HTTP OMS data collector, the API, the amount of data will grow massively, and I'll be able to easily search upon this data based on specific criteria and search strings. The amount of integration points that there is to offer in OMS is massive. Last year there was less than 1/3 of this amount. Now there's a whole page full of integration points. What is an integration point? An integration point is a way of integrating OMS with a third-party product or service. It's a way of expanding OMS to suit current investments. Let's take a look at PagerDuty, for example. PagerDuty is a web service that you can use to call your mobile phone based on an action. We can make use of the vast array of data in OMS, create a search query based on this data, and then associate this search query with an alert. Creating alerts in OMS allows the ability to send email directly from OMS itself based on a schedule. Or you can use the option to make use of a webhook URL. Let's look at a scenario. You can use a webhook URL provided to you from a third-party service. The webhook URL can be provided by a web service like PagerDuty when you set up your account. A webhook is just a web service that listens out for a connection. That's all it does. The next time an alert is triggered in OMS, the alert is sent to the webhook URL, then PagerDuty takes this information and does what it is configured to do with it. For example, make a phone call or several phone calls. The custom logs data source and Insight Analytics allow you to collect events from text files on both Windows and Linux computers. Many applications log information to text files instead of standard logging services such as the Windows Event Log or the syslog. Once collected in OMS, you can pass each record in the log into individual fields using the custom fields feature of Insight Analytics. We'll take a look at custom fields a little later. In this demonstration, we're going to demo OMS custom logs. Now, let's open up our company software. And the company software is a little bit unique. It's radio station automation software. And you can see there's a whole bunch of things in here. There's a song it's playing. It's got 2 minutes remaining time, and it's been playing for 1 minute over here. Now, this software, just like other software, has a log. Now, let's open that up. We'll go up to the top and we'll open up the general log. As you can see in the log viewer, this is the contents of the log, and there's anything and everything in here. There's a whole bunch of things in here. Voice tracks, errors, songs, the whole lot of things. So all of that information is perfect to ingest into OMS, because it would love to grab that data and suck that all in, and then we can do stuff with it later. So let's do that. We'll go to the OMS portal and we'll import this custom log. We'll go up to the top and click on settings. And on the left hand side under data, we go to custom logs. And in here, we want to add, and we want to browse to a sample custom log. Notice it's a sample. We don't want to add the exact log file in here just yet. It's just a sample. So we'll navigate through to the location of where the logs are kept for this program. And here they are all here. Now there's a new log for each day. That's fine. We're just going to select one of them as an example, because they're pretty much the same except for each day. So let's select the top one and let's go next. And on the next page, you'll see there's two options to select from here. There's new line or timestamp. Now, if we have a look at the timestamp on each line of the log file, you'll see there's a certain format and a syntax for the date/time. Now, it's not always the case you're going to get a match of the exact date and time with what's listed here in the drop-down list based on regular expressions. So in this instance, we're not going to get an exact match, so that's fine. So we'll click on new line and that's acceptable. And we'll go next. Okay, here it's asking to enter a path, and this path is applicable to all computers or agents out in the field to tell them to point to their own log file. So if you've got several computers out in the field and they've all got this program installed, this is what you would put here is the path common for each computer. It has to be generic. So let's go to the logs file folder first, and we'll navigate through programs x86, station playlist, and logs. So we'll copy the location to the clipboard and we'll go over to OMS. We'll paste that in. Now it's going to be a bit specific. See the C drive at the beginning? We don't want that because not always the case that you install Windows on the C drive. That's fine. We want the system variable, and to get that, we open up command prompt to get the system variable. And here we type in the word set and then enter. And a whole bunch of system variables exist in Windows, and these are all common across the board. So if we scroll down the bottom under system root, you'll see, or system drive, you'll see one that says it points to C. So system drive is, in other words, the drive where Windows is installed. So that's perfect for us. So it's % system drive %, and then it'll be backslash, and the rest of it will remain the same because that's common across the board. And then we'll put a backslash at the end, and we'll put a name of the log file name, because each log file is listed and named slightly different for each day. We want to ingest all of these log files. So we want to put in what's common for each log file, but then leave out the bit in the middle which is different, which is the date. So let's do that now. So we'll put the whole log file in, and we'll just highlight the bit that's different, the date, and we'll put a wildcard in there, an asterisk, which is what we do, and that tells OMS to pull everything that it fits within this criteria. So once we're happy with that, we'll add that in. We'll click on the plus sign. And it's accepted that, it's happy. Click on next, and here it's asking for a name. This is the last step. You'll see here by default it's got _CL, which stands for custom log. We'll give it a name, station playlist log, and click on done. And that's pretty much it. So that's going to go through and take that information into OMS that you've added in this custom log. It's going to go and talk to the agents to say, hey agents, I've got this custom log here. I'm looking for this specific criteria of a log file. Give it to me. And the agent will go and send that data up to OMS over 443. It'll hit blob storage. OMS will sift through it and filter through it and do stuff with it and make it look pretty. It'll add it to the SQL database in Azure SQL, which is underneath OMS, and it'll allow you then to go through to log search and do searches upon that data. And one step further than that is custom fields, and the custom fields area is what we'll have a look at next. The custom fields feature of Insight Analytics allows you to extend existing records in the OMS repository by adding your own searchable fields. Custom fields are automatically populated from data extracted from the other properties in the same record. Right, this is the next demo for custom logs in OMS. The first part of this demo, we looked at setting up custom logs in OMS, going through the motions of that. And this demo, we're going to go and have a look at searching in custom logs and also setting up some custom fields as well. So let's do that right now. We'll click on the log search icon on the left-hand side in OMS. We're going to put a search query in here. Now the search query will be quite a simple one. Type equals station playlist log underscore CL, which is the name of the custom log that we created in the demo before this one. You can see here there's 201,000 results, which has already come through. So that's pretty quick. And if you have a look at the timestamp, it's today's date, it's 54 minutes past the hour, and the current time at the moment is 55 minutes past the hour. It's only 1 minute difference. The difference being probably not OMS, it's probably the difference is that this is the last entry that's written in the log file. So let's go and have a look on the actual source system, shall we, and see where the data is coming through from. So this is a source system that you saw earlier. There's the radio station automation software, and if we have a look at the logs folder, which is here, and we've sorted by date modified, we'll pick up the last modified log file, which is essentially as of now. Scroll right to the bottom because the last entry is written down the bottom, and you'll see here the timestamp is 55 minutes past the hour, and you've got 3 entries at 55 minutes past the hour. So let's go back to OMS and let's click on refresh or search, and we should be able to see a replica of those 3 log file entries at 55 minutes past the hour. If not straight away instantly, it'll happen within a minute or so. So we'll click on search again, and there they are. So it's not only picked up that there are 3 entries at 55 minutes past the hour, which you can see here, 1, 2, and 3. It's also picked up one new one in the time that it's taken us to flick back to OMS. So it's pretty much up to date as of right now. That's amazing stuff. So what we're going to do now is, now that you can see the data is coming through in sync from the custom log that we set up from this endpoint, this computer on the internet somewhere, we'll set up some custom fields. Now, custom fields are fairly interesting because it's a particular field in amongst the custom log file. So let's run through that now. So this radio station automation software, it has a web front end, and if we go to it now and click on it, this is a web portal. We can scroll down and type in the name of a song, for example. So if we put in, say, Queen as an example, as an artist, and we'll scroll down now, we can see a whole bunch of songs here from Queen. Let's just click on one of them, Bohemian Rhapsody. Am I sure? Yes, it's going to go through. It's requested that song. Now, if we minimize this and go back to the computer on the internet, and we can see already that that was quick. Queen Bohemian Rhapsody has already been picked up. We just requested it and it's now playing. So it looks like it's requested it, it's grabbed the song, it's playing it straight away. Now that information should be in the log file pretty much instantaneously on the actual computer itself. And there it is there. You can see the second last line, request received, is Queen Bohemian Rhapsody. And then the last line there you'll see is where it's picked it up and it's actually playing it. So let's head over to OMS. So what we'll do, we'll click on the search button again to refresh the logs coming through. And there you have it. So it's already picked up the latest entries in the log file. And we scroll down a tiny bit and we can see there the entry that we're interested in. It says request received is Queen Bohemian Rhapsody. So there it is. Now, if we want to set up, say, a custom field, which can then be turned into, say, an alert, and we can add that into the dashboard of, let's say, request received. So let's imagine if we want to sort of track or do up an alert of requests that are received on this radio, with this radio station automation software, we can do that quite easily. We can then go on the left-hand side here and click on the little ... and down the bottom here, it's got an option to extract fields from the logs. Let's do that right now. Okay, so what we do, we can see this string of text here, which we want to set up as a custom field. It says request received, so we'll highlight that string of text, and it comes up with a box. Field value is request received, and it needs to be given a title. Now, as you can see, it's got _CF there, which is obviously stands for custom fields. So we'll type in request field. We'll put a 0 at the end. Field type is text, and let's go extract. Okay, so that's done. So what we can do now is save the extraction. It's currently saving at the moment. Now, if we go back after adding in this custom field and request another song, let's put in excess, for example. Scroll down. Okay, I'm going to request in excess disappear. It's going to take that song through. Thank you, your request has been submitted. We can have a look at the back end. There it is. It's popped up. And if we check the log at the back end, we should see it's been updated already. Let me just bring that up here. The last log. The song's currently playing right now because it's just taken it as a request. And if we refresh, double click on the log, scroll right to the very end, and we can see the two entries in the log file, request received, and also the other entry here, which basically indicates that the song's playing on the computer on the internet. So let's close the log file down. Let's flick back to OMS and have a look to see what we can see now. It's currently 16 minutes past the hour, and we can see here the time difference. If we click on search and see what logs we can pick up. And there we go. It's picked up the last couple of entries in the log. One of them is request received. Now, if you have a look on the left-hand side here, it's got request received. That's the custom field that we set up. It's picking up 2 requests received in the logs. It's also here's the entry here. If we have a look, you can see it's got another area here called request received. Now, if I click on here and do a search, and it'll bring up all request received custom fields in the custom log, we can then do things like we can save this log search as a favorite log search, and we can add that to the workspace. So let's do that now. We'll save that and give it a name. Call it request received, and the category is let's say general exploration. Save that. Okay, if we go back to the dashboard over here, click on Customize, scroll down under General Exploration, Show All, and we'll see here our log search that we've saved. So we can go plus and add that to the dashboard. So there we go. We've added a custom field from a custom log to the dashboard. We can click on this, we can go back into the log search area, you can see exactly what songs have been requested, what time, in close to real time, and what's more, we can click on this button here and we can create an alert based on this search query here. And we can set it up to send us an alert every so many minutes to an email address, or we can create a webhook or whichever else. So that's it. That's custom logs and custom fields in OMS. Okay, we've gone through a lot. Here's a quick recap on what we've covered. An overview of OMS, how data can be collected and sent to OMS, custom logs and custom fields, integration points with third-party services and applications, the OMS architecture, integration with existing monitoring products, Nagios and Zabbix, cross-platform support for both Windows and Linux, and multi-public cloud support including Azure, AWS, or Google. It's a lot to take in. It might be a good idea to take a look yourself. How do you get started with OMS? That's it. On the next webinar, we discuss OMS protection and recovery. You can try out what you've seen today or any of the feature sets of OMS. Simply create a free account, aka.ms/MSOMS. Stay up to date with OMS on Twitter by using hashtag MSOMS. If you qualify, you can take advantage of the Microsoft OMS Accelerate offer to have a Microsoft-funded proof of concept so you can see for yourself the advantages of OMS in your very own data center. Contact us for more details. Thanks for watching.